Hey everyone, like today we'll start with designing a search autocomplete system, that is Google search, right? So if we see in a general search, uh, how do you search? Like if you type something, then it kind of suggests you ideas, right? Dinner ideas, dinner recipes. So whatever is relevant to the user. So that kind of search system, even if we go to any e-commerce website, then also it shows you all the search relevant search, like product search or maybe relevant to different categories. So that is the kind of system we want to design, so that it returns a top k most search queries, right? So top k, you don't have to show millions of search, just top 5 relevant searches. So that is the design. So there could be questions from the candidate, like is the matching only supported at the beginning of a search query or the middle as well? So it says at the beginning of the search query. So as you are typing, you are shown the search results. It's not like the middle thing also has to match. I think that is meant here. Yeah. So how many autocomplete suggestions should the system return? This is a really good question. So around 5. So 5 results we have to return. Does the system support spell check? No, the system spell check or autocorrect is not supported. So I mean by this, it means something kind of a fuzzy search, where you, if the user types something wrong, let's say in the spelling of dinner he misses n, right? So it should be able to understand that the user is trying to type dinner. So some kind of fuzzy search logic it should have. I think that is required here. And so we are currently focused on English, one language. And do we allow capital or special characters? So for now we will consider only alphabetic characters. And how many users use the product? So 10 million DAO, right? So that is daily active users.
Yeah, like this one is also important. Like, I mean, how, on what basis top 5 suggestions will be returned?
Yeah.
So,
So I think if we go here, then basically we are more concerned about uh, the fuzzy search, right? Fuzzy search. And second point is 10 million
no,
active
we are
users.
not supporting for this, right?
We are
Yeah,
supporting,
the
right?
no, the chapter doesn't support, but yeah, like,
No, here they are meaning that, or I mean, where was it written? Does the system? Oh no,
no.
okay. It says no, so we are not concerned about that, right, Vishal? You are right. So let me just remove this. So we are not concerned here about fuzzy search, but that could be one expectation, that if let's say the system supports fuzzy search, then how would your design be different? That is one thing we can think maybe. And top 5 uh, search results, and from the beginning we have to think like uh, it should match basically. And what else? English language only. And fifth thing is like we will support only lowercase, right? That is what I can see that the author has mentioned here. And if time allows, then we can discuss about multiple things. Okay, so requirement wise, it is a user types a search query typically, and it must be fast enough. For example, for Facebook, autocomplete reveals that the system needs to return within 100 milliseconds. So latency is important, right? It should not happen that user is typing a search and he has to wait. It should be instant, which is really important. And then the results written by the system should be sorted by popularity or any other ranking models. Okay, this is interesting. Like, how would you maintain the ranking? And it should be scalable for a high traffic volume, and system should remain available and accessible. So yeah, so I think these could be some non-functional requirements, where we are saying that our system should be scalable, and it should mm, available, low latency, up to we can say 100 milliseconds, right? And what else?
Yeah, that's it. I think 3 non-functional requirements are enough for an interview.
Yeah. Okay, let's move on. So back of the envelope estimation. So in the estimation wise, I think we should be concerned about what is the QPS we are looking at, right? So I'm just thinking out that if let's say we have 100 million use 10 million users, and these are the daily active users. So we are concerned about the QPS. What would be the QPS? What would be the storage? Do you think that we require here? What would you store? uh,
So
so you,
all the phrases with the frequency we have to store.
yeah. Hmm. Yeah, and one thing I can think that we have to also support ranking also, right? Ranking and popularity. Okay, so whatever the user is searching, so I think we have to store that search so that later point in time it is more relevant to the user. Something like that we can store. Okay, fine. Let's see what is here. So average person performs 10 searches per day and 20 bytes of data per query string. Okay, and we use ASCII character encoding and one character equal to 1 byte. So query contains 4 words on an average. Each words have 5 characters. One character is 1 byte. So total 20 bytes per query, and user searches 10 queries per day. So 10 by 20, 200 uh, into 10 million would be your this thing, I think. Total storage. Still trying to understand what is meant here. On average, 20 requests are sent for each search query. So what I'm trying to think, they are saying that one user searches 10 queries, okay, and one query is equal to 4 words, and one word is equals to 5 byte. So uh, one word is equals to 5 byte. So total one query is equals to 20 bytes, and so total, I'm just trying to do the estimation. So there would be for one user there would be around in a day 200 bytes per day, and if you have 10 million users, it would be 10 million multiplied by 200 bytes per day, which would be equal to 2000
Megabytes, so 2 GB.
yeah,
Yeah.
2000 MB, that is 2 GB, right?
Yeah.
2
Yes.
GB storage per day. Okay, so let's see what they have done. They have assumed some on average 6 requests are sent to the backend by the time you finish. So what actually happening here is that as soon as you are typing the word, right, a query is being fired. So
Yeah.
then it is returning some search, then you type another word, then another thing. So on an average user will type 4 words, but what is here, like why 20 requests are sent?
Because we are expecting 20 characters can be there in 4 words. So
Okay.
character by character there will be 20 requests.
Oh, is it? Okay. The following 6 requests are sent to the backend by the time you finished. Okay. So for example, dinner has 6 characters. So for each character there will be a request. So it would be this, and okay, understood. Makes sense. So then we will query in a similar fashion. Uh,
Like
just
how, like, can you once again I
so
trying.
I will try to explain. There are 4 words. Okay, 4 words are there. This is an example, like 6. On an average, they are saying 20 requests because each word would be around 5
If your
characters.
page have length of 20, it will be 20 queries. Here they have given just an example. When you type dinner, there will be 6 requests. You are requesting for type at suggestion, because when you will type D, then a request will be fetched from the server, then DI, then for DIN. So
Okay.
total 6 requests for dinner.
So it's assuming like on an average, like 20, I mean, like 20
Yeah.
characters requests are being sent.
Yeah, so
Right.
because what happens is like there are 4 words and each word is a 5 character. That makes it 20 characters, right?
Oh, okay,
So
okay.
total 20 request. So yeah, so storage wise, I think we have to multiply also. I think have we considered that in our that is the
Yeah,
question.
you have.
We have, right?
Yeah.
Okay. So let's go on. So QPS wise, they are trying to divide by 3000 per day we have calculated. So if you have to calculate per second, then you have to divide it by 24 multiplied by 3600, right? So we can do the math there, and it should be something close to 48,000 queries per second. Peak may they have assumed it would be twice, so something like that, and 20% of this daily are the new queries and other can be old. So 80-20% rule they have applied, something like that. This means is added to the storage daily. Okay, so even if we take I mean if we take 20% of it, how much it would be?
0.4 only.
0.4 only, right? Because 20% are the new queries, 20% are new queries, it will be
This is just an assumption. In the real interview, be careful about the time you are spending here. When you have to compute query per second, just divide it by 10 to the power 5
Mhm.
instead of 3600 into 24, because
Okay.
that will take a lot of your time. This is just an approximation.
Okay,
So
so we can say this day can be around 10 raised to the power 5. So we can do the quick math there, right?
Yeah, it's always better to do a quick math. What I've seen that most of the interviewers are not interested in these
Yeah,
calculations. They are interested in
exactly.
the design.
Hmm.
I usually prefer to do this computation when it impacts my decision. Like I have to figure out whether my complete data can sit on a single server or not, because that will impact design. That then I need shard if my complete data cannot sit on a single server, and the application strategy can also change.
Hmm.
So since the storage is 0.4 GB, I can assume that it can sit on a single server. So I can just have I don't need a data partition in this case for just single day. I'm not talking about the whole year.
Hmm.
So in that case, I can make a strategy like that. My complete data will be on a single server, but for fault tolerance, I can have our application on
Yeah.
other server, but a data partition will not be needed.
Yeah,
So
so by this amount of data, I think we don't need sharding, right? We don't
yeah,
need.
this is just for a day. So I am just giving an example.
Yeah.
Usually you compute it for 5 years or 1 year first, and then you make
Hmm.
calculate all those things. But don't expect too much time here. If the design decision can be impacted by this calculation, then only do it. Otherwise, most of the interviewers are not interested in that.
Yeah, agreed. Yeah, yeah, it's a good point. Like, we should see that, like, even if we are, let's say the interviewer wants us to calculate, since we asked, like, do you want me to calculate? Then, if let's say the interviewer says to you that, please go ahead and calculate. So you start calculating, and if you see that you are taking too much time there, then you should just park it for later. You can say that, let's move on. We can come back to this later, right? Uh,
I
because
agree. I agree. So
yeah,
usually I say that if I think the decision can be impacted, I will do this calculation. Otherwise, are you okay with if I go to the HLD part? And
yeah,
most of the time they are okay with it.
yeah, yeah,
No issue. And if they want to compute, they will say how many machines. Like they will ask an indirect question instead of do the calculation. They will say like how many machines will be required for the storage. Then
Mhm.
you need to figure out how much total data is there and how much a single server can store. Then divide it by that to figure out the total
Yeah,
number of servers.
yeah. Actually, it happened to me in one of my interview where I asked the interviewer that, "Do you want me to come do the capacity estimation?" So he pointed me that, "Yeah, please go ahead." So I end up asking around to, like, if you need to calculate, you should ask all these things, right? So it will take some time for you to ask these things, and then you have to calculate as well, because you already asked the question. So I end up spending around 10 to 15 minutes of my time, and ultimately, like, that was not needed. So I was supposed to design the DB schema and stuff. So this took a significant time, due to which I was not able to complete my design. So that could be one reason. So you should, even if the interviewer says that go on, you should evaluate and move ahead. Yeah. Not every calculation is required. Okay, makes sense. So so step two is like getting, once we are done with the requirements and capacity, we can start thinking about the design. What all services, what all components would be required, and how would your system be scalable and fault tolerant. So that is how the author will try to discuss here. So they have created two service. One is data gathering service, another is the query service. So in the data gathering service, it gathers whatever the user is inputting the queries and or aggregates them in real time. Okay, and so real-time processing is not practical for large data sets. However, it is a good starting point. We will explore this. Okay, given the search query of prefix return 5. Okay, so essentially they are trying to say there will be two services. One is the data gathering, and another is your query. So query service will return you top 5 results, top 5 search results, and data gathering service will aggregate data in real time. But if the data is large, then we will not do it in real time. That is what they have said. So is this like the search, like a search flow? Both the services are for the search, not for storing, right? We are not storing anything here right now. We are just
No,
uh,
data gathering means writing only, right?
no, but it aggregates the data and then
So data gathering is more like I think the search results that you are getting. So now when you're clicking any, let's say dinner, like dinner place or something like that. So that as soon as you click, so then like it will just aggregate its popularity.
okay. So yeah. So
So
And
let's
this
it
is
will
different
just
from the other questions. Just for tech tourist, I'm saying, like if in your search query only you are kind of gathering the data. So you are writing that as well. That now for this query the frequency will be increased by 1, and you are giving the response for the search as well. So both things are happening here together. The data
okay,
gathering part as well as the search part. It's not a two separate APIs here.
okay. So
What we
okay,
usually see in other questions that there is a separate write flow and there is a separate read flow.
okay. So both the things are happening at the same time. So assume we have a frequency table that stores the query string and its frequency. Okay. So they are kind of maintaining a table where your search query is there and the frequency for it. So, but do we really need to store the frequency?
so that's how they will compute the top popular top popular query.
Search results.
But here like I think they are mentioning, I mean they are mentioning that, so let's say you are searching for di, then di frequency will be incremented by 1. Now if you are din, then that will be incremented by 1. So that is what is happening here.
And based on frequency only, you can say, na, these are the top 5 items based on popularity. If you don't store the frequency, how will you know the top 5 items?
Yeah, but I think what I can do here is that this service, right, instead of just having the count, it could be a combination of certain parameters, right? Maybe something like frequency is one parameter, then maybe some I can have some inputs from uh, maybe like the historical data, some parameter, and then some trending data, something like that, right?
Historical and trending both comes in frequency, right? So whatever has been
Yeah.
searched in the past, that will increase the frequency. That will be counted in the frequency actually.
Okay.
Yeah,
Mm,
and popularity is also like again the same thing.
So one
Whatever
thing
is
that
your
can differ
top.
is our personal customization. Like I'm used to my language Hindi, so basically there might be a custom words used by a particular user, but we are not taking that in the functional requirement here. We are just
okay.
talking about the global used words. So
Okay.
for that, frequency is enough.
Okay, so yeah, I agree. Like this, everything will be come into frequency only. Okay, so just we will maintain a map kind of thing here that this is the query, and query service will just query that, right, based on the frequency. Okay, let's move on. So this is the frequency of words.
But
So
like I have like one, I mean like one doubt. So basically for popularity, I guess like more sense. It will make more sense if we take into account like any like suggestion like number of clicks on the particular suggestion, right? So when user is searching like din, then basically let's say dinner table or something like that. So if like 10 users has clicked on let's say some suggestion that is dinner table, so that will be like more popular.
Yes, I agree. So when you click on something, that means you have searched for that phrase. So it will increase the frequency. But it can also happen that what you want to search is not there in suggestion. So whenever, in that case, you have to type enter for the new, it's a new phrase basically. You don't have any suggestion for that. Then also it will increase the frequency for that phrase. So both are possible here. And this table will increase the frequency when we press enter or whether we click on a suggestion.
Okay, yeah, that also makes sense.
yeah, I mean, but one thing I'm trying to understand that you cannot store. How would you know that the word has been typed? I mean, with space or something, we can keep that information. Or for
No,
example, here the user is
If you
typing.
see if you see the last word here, twin space peak in the table, so they are including a space in the word as well.
Okay. So for example, as soon as the user is typing, for example, TW, right? So do we store T, then TW, then TWI? How do we store that?
yeah, so like I mean like based on the application, like I mean if you are suggesting just after like one character, then like you can store t also. But ideally like any autocomplete or search application that will ask for 2 to 3 characters, at least 2 characters, then they will start showing the
But what
suggestion.
do you mean by store here? We are not increasing the frequency of TW here. So that right call will only go when you either click on enter, like after TW, you are okay with this phrase, like this is your complete phrase, or whether you click on some suggestion, like you click on the Twitch, then
Mm,
it will store Twitch. It will not store TW.
yeah.
TW is used for the lead part here. Like you will get all the auto suggestion for the TW, but in backend you are not increasing the frequency of that because user has not
Yeah, I
did
mean,
this.
there could be two events, maybe one for the space and another one for the enter. So based on those two things, we can determine whether it is a word or a phrase. So we can have a word search. For example, this is a word search happening, and when let's say you type Twin Peak, then there would be a phrase search kind of thing, which will give you Twin Peak SF as a auto suggestion.
Right.
So we can consider two things like a word search and a phrase search kind of thing. But yeah, that's okay. I think something like a prefix, a wildcard they are using as a query, so that makes sense. So whatever is like the wildcard, then all the things. Okay,
Okay,
so
so okay, so essentially like okay, what we have concluded like I mean, like when you are, let's say you are typing like TW, then like all these suggestions that are shown, Twitter, Twitch, Twilight, so all these frequencies incremented by one, right? And then like when you click, let's say after TW, you make enter, then like search happens for
mhm,
TW, or if you click on Twilight,
yeah,
then basically search happens for Twilight.
yeah,
So in that case, like for TW or Twilight, like like I mean, frequency increment operation will happen once.
yeah, yeah. And also one point I can understand, like just my observation is that the word search count would always, most of the time, would be greater than the phrase search, right? Because there are 10 million users, and most of them would just type a word, right? They wouldn't write a complete phrase. So in that case, first we can just show I mean the word search and then the phrase search. Something I'm just thinking in that direction, but I'm not sure in this design what is accommodated. But just those are my ideas. Like first we can show the word search, then the phrase search. Yeah. So this is an acceptable solution when the data set is small. When you have small data, then this is fine, but when it is large, then querying, like if you query using this SQL, then it becomes a bottleneck. So now author will explore the different data structures.
Yeah. So
To
one thing here, like if you suggest like MySQL solution first, and then if you counter it like why it doesn't work, then probably like making some calculation here will be good point or good like effective thing.
like, what do you mean by calculation?
Calculations isn't like, so now like let's say you have 10 million queries, and then right like
Okay, okay, in that sense, okay. So yeah, makes sense just to trade off, like we can just trade off that this is not an optimal solution where you are storing everything into a DB and querying, running a SQL query, and it's not scalable. So yeah, so basically we can explore some data extraction where you can search the things in a trie. So trie kind of is a prefix based search data structure where all the nodes are divided into the, like, top to down, it's divided based on the child parent relationship. And here the search is optimized, it would be logarithmic in time. So what we can do is whenever a user is typing something, we can store that into a trie and do some processing maybe on it. Yeah, so let's see what is discussed here. So they are talking about here the trie data structure. uh, so relational databases are used here, so fetching the top 5 search queries in inefficient. Trie can be used here to overcome the problem. So we will discuss to customize trie. Maybe like some optimal is that like we can store a combination of words in a single node. Usually in trie we have something like a, then let's say t and then e, and then you can have a node which is, let's say, a, p and e, and a, p and let's say t, right? So just assuming that, then so if let's say this is a structure, then what one optimization, I think they might talk later also, that you can club, like instead of a character, like you can maybe store ate and ape in a single node. uh, and similarly, like we can maintain some parent child relationship and something like that, because there are so many words, right? So we can make a cluster of nodes of similar words, uh, something like that we can think maybe, but I'm not sure. Does that make sense?
Yes, for fast searching, we need to do some variant of try which can help in the fast search. Like for the child node, we can have a pointer to the parent node, and parent node might store all the string that is possible from the its subtree based on the frequency. There can be certain optimization that go through this in book,
Yeah,
like
yeah,
what they have.
okay. Okay, let's read it through what is discussed here. So however, this is there is a data structure question. So besides many online materials, in this chapter we will discuss an overview of trie and how to optimize the basic trie to improve the response time. So it's a retrieval kind of data structure, tree like structure. Root is an empty tree, then 26 characters. So basically they're discussing what is a trie. So t would be there, then r would be there. It's just a node, but basically, yeah, I mean, final word would be tree if you traverse from top to down. T, it would be TREE, right? So that makes it tree. TRUE, that makes it true, right? So this is a basic trie, so nothing to think about. But how would you store the frequency? So each node can have its own frequency. So that's how you can store the frequency, I guess. Yeah. In the node itself, we can store the count, but this is not the optimal trie, right? It will again end up traversing all the nodes. And we need just k most search queries. Okay, so maybe these are the things. P is your length of the prefix, N is the total number of nodes in a trie, and C is the number of children in a given node. So number of children would be here 4. I mean 4 if we consider the root. So it would be C log C for the traversal, and order of P. Uh, so is it order of P because for each each I mean while the user is typing, so for each character a query is fired, so it is order of p. And then total number of nodes in the trie, so that could be because we have to, if we are to return top k results, then we have to obviously go to every node and check and then filter out the k result. So that would again take order of c time, not c, it should be order of n, right? uh, what is this order of c? Traverse the subtree from prefix to get the valid children. Okay, you are going to each child and then checking, okay, but shouldn't n equal to c here? Oh, C is for a given node. Okay, fine. At each node, they are storing the child. But why do we need it? So for every node, they are sort of storing the number of child present in its subtree.
Yes, that's how you map child nodes now.
Yeah, mapping is fine, but why do we need the count?
No, if you have all the child nodes, you already have the count, because to search you have to basically kind of iterate over all the child.
Yeah,
So that means you are iterating over this total count, which is C.
okay. So for 26 characters, uh, if that is lowercase, so we will iterate 26 times for a given node, right? That is what you meant, Vishal.
Can you repeat? Sorry, I didn't
So
hear.
there, let's say there are lowercase alphabet, so there are 26 characters. So 26 child nodes would be there, and we will iterate 26 nodes.
Not always 26. Let's say only 3 words have been added, tree, try, something like that. So you only have those child nodes. Like for T, you have R, you have TY, if there is word starting with TY, and for thank you, you have TH. So H, Y, and R are the child nodes of the T parent node.
Mm-hmm.
Only 3 nodes are there for now.
Okay.
But maximum it can go to 26,
Yeah,
right?
that's what. Like generally, like we initialize them array of 26 and initialize all of them as null.
That is just a
Uh,
simple data set we use. But in production level code, you will have a list of child nodes
yeah.
to save more space of the child node side. So you won't initialize it statically, like have a space for all the 26 characters. You will just uh, you want to keep it dynamically, like a list of characters you can give, and whatever child nodes you need, you will append on that list. So there are many way to implement a try. So
Mhm.
instead of having a 26 character that is a fixed array, you have better ways as well.
Okay, understood. So yeah, so they are saying that there is a further optimization which we can do, which is limit the max length of the prefix or cache the top search queries at each node. So what is meant by limit the max length? So users will not write a very long text. So they are assuming that maximum it would be of length 50, and we can say if the limit the max length, the time complexity of find the prefix would be reduced from order of p, which was here, to order of constant O of 1. Another way to optimize it, at each node we do a caching, so that we don't have to search it again and again for so yeah. So if you store it, then you are trading for time. Okay, but one of the requirement for us was that it should be fast, so that is why it's better to cache. So that makes
Okay,
sense.
but like one thing, so here like then the cache will be updated at every every like read and search, right? Like I mean for each write operation, you need to update the
So I
cache.
think, yeah, that is right what you said, but we can do the optimization on that there as well, because we don't need strong consistency in this case. Like let's say I added a new phrase in the Google search, but I don't need to see it immediately.
Hmm.
So you can assume that you can do some kind of data aggregation for 1 hour, and after 1 hour you will basically update in the existing trie data structure.
Yeah,
So you
it
don't
would.
need to do it for every read. You can do it based on some interval. Like after 1 hour, I will keep updating the trie. So it's okay to get scale data, not
But
immediately.
okay, but yeah, that's fine. But like I mean, there will be like eventual consistency. So you want like correctness, right? So basically, for that, like I mean, for all the words, like all the suggestions you get, and all the words you have clicked, you need to send it probably like asynchronously to some service or some queue where like you can aggregate that, right?
I agree. I agree. We can do that, but one thing I'm thinking that maybe Google does not store it for every query we do. Maybe it does kind of sampling. Let's say out of 10 requests, I will just add only one request in my backend. I will ignore the top nine because in this case it does not matter that much. So if we want to have read request reduced by some point, we can do that. But I'm not sure whether that is some
Mhm.
optimization I want to do. But you are right. For every read, we need to basically gather in some service, store it in memory, and increase the frequency. And after an interval, update in the Trie data structure.
Yeah.
Yeah, so this try can be updated in some interval of time. Like if let's say there is, we can pile up the data, and this try can be updated at some intervals, and uh, yeah.
Like that will pose one question, like how basically, like I mean, what kind of like yeah, following like I mean, leader to follower or leaderless architecture, right? I mean, like because like your reads can happen at the same time, like when this write service or this aggregation job is happening.
Yeah, but I mean, it won't happen that all of a sudden your search has changed, right?
Yeah, I think from there are multiple ways. Like you said, for single leader application can also work that we have a slave and we do
Yeah.
update in every interval in that particular slave. And when that is updated, then we change it to master. And
Mm.
Yeah,
after that, the original master can sync from that
Yeah.
slave. So some kind of strategy we can use. I think there
yeah.
will be multiple ways.
Single leader will make more sense, kind of.
Yeah.
Yeah, for now it makes sense.
Yeah.
I don't know about upcoming
Okay.
complexities.
So let's move on to the next thing. So here they are saying there is a root, then you at b you are storing the total number of child it is having. So that would be best bet b by, and accordingly their frequencies are also stored. So for example, user types be, then I think these would be resulted in the top five or something. Is it five? One, two, three, four, five. Yeah, five results. So yeah, something like that we can store, where at every node we are storing the count, as well as we are caching the entire thing below, if I'm not wrong. Yeah. So the prefix node time complexity is reduced to order of 1, which was order of p, so it was got reduced to order of 1, and top k, which was order of c, is also they are
See,
saying.
one thing like this will increase the write complexity. Like just okay, just like saying it out loud. So let's say like your like you have searched for, let's say, best. So like traversal is happening, like starts from B node, then it goes to BE, then it goes to, let's say, BES, then it goes to best. So now like finally like at best it has updated the count of frequency to, let's say, 35. Then like it has to traverse like up and then update the cache, right?
Yes,
So like update the cache at each node, like it basically needs to update the cache at each node.
yes.
So write becomes like costly.
Yes,
Yeah.
and they are deliberately doing it because we need lesser latency for the read part. Right, we can do in interval, we can do offline. Offline means that user will not be querying from that particular node where we are writing. Right.
Hmm.
So writing we can do asynchronously in some slave nodes. So user is not bothered about that. So we can afford to have a high write latency, but we cannot afford to have a read latency because meanwhile I'm typing, I should see the auto suggestion immediately. So we want less. So there is a trade-off. We want to improve the read part, and
Yeah.
that's why write it
No,
becomes.
but I don't think that right. Obviously, overall latency would increase, but that is a different flow. Why I say this, because we are having a cache. So cache implementation would be different from the try implementation, right? So cache.
No, what Shubham meant, let's say you search for best. Now you have incremented the frequency for the best node. Now you also need to increment the frequency for the parent as well, like for B,
Yeah.
B, that will also increase. So that's where write latency is increasing, right? From the bottom node to the top node, you have to increase the frequency of
Okay.
every node, and then you have to compare that for the five words that I have stored, whether this frequency has been updated, whether it should come in that list or not. So
Okay.
that part you have to do in every write. That's why
Hmm.
it's expensive.
Yeah, makes sense. Okay. So yeah, it should be updated everywhere across the nodes. So, but that could be done offline also, right? I mean,
Yeah,
uh,
we are doing that offline only.
so how would
I mean, yeah.
increase the latency? That.
Yeah, just like for the, so yeah, like so that's what we are saying, like basically yeah, let's say when you are searching for best. So now like so now it can, like, fire all these as events, like I mean, being count has increased, then BE count has increased, then BES count has increased, then
No,
B,
count increase is fine, but that you
yeah,
can do
and then like,
offline, right?
and then you need to update the cache also. So after you have got the aggregated counts, so now like at B node, you will compare,
Mm-hmm.
all the other basically words
Okay.
and their frequency. So yeah, like here you will, so yeah, like your top is best, let's say. So
Hmm.
then, so basically, like, yeah, you are traversing all its child,
Yeah, understood.
comparing
Yeah.
all its child,
Hmm.
and it's yeah, basically like it's neighboring child also, right?
Okay, fine,
And
fine, fine.
then and that also like you are updating at each node,
Okay.
each parent node, like.
Hmm. Yeah, so basically, yeah, anyways, like complexity wise, it will increase latency. I'm still not convinced, but yeah, okay. So that is okay. Yeah, so let's move on. So that was the first service. What were we discussing? We were discussing about the trie data structure. The first service is the data gathering service. So we understood like how we would create a trie. Now we will talk about like how we will gather the query results, uh, the aggregated query results. So data is updated in real time. This approach is not practical for two reasons. Okay, for every query, it slows down the query service. So there's an analytics log, then they are calling aggregator data workers updated weekly in the trie db and trie cache.
They are updating it weekly instead of all.
Yeah, they are saying that it is very expensive to update it real time.
मुझे लगा अर्ली करना ज्यादा लेट कर रहा हूँ मैं, तो वीकली
Okay,
करना ठीक है.
users may enter billion of queries per day. uh, Updating a trie on every query significantly slows down. Yeah, this was, I was saying that top suggestions will not change with every search the user is making. It would still be the same. So that is the reason we need not update the trie, right, every time we are querying. But
Right.
yeah, so because once, let's say you are we are thinking like we are building a system, but let's say when the system is already for 3 months or 4 months, you already have a lot of data points, so that over the time your ranking and everything would automatically improve. So you we might not we can delay the frequency initially when your system is there, then you might have to do hourly or per day, but when the system is mature, then you can do it weekly as well.
I think like when the like system becomes large enough, then like the frequency change will be like very less. I
Yeah,
mean,
yeah, because the user patterns would be same and a lot of things would be same, so that is why they have created some analytics kind of thing which analyzes whether you need to update it or not.
Most of the time that will be the case. Sometimes it can happen. Some trending search has
Hmm.
changed the tendencies.
Yeah,
Like Gukesh won the chess
yeah,
championship. Now people will be searching for the Gukesh, and
yeah.
those people didn't even know about him before the
Hmm.
championship. So
Exactly.
now it will come in the search part. So yeah, but I agree with your point.
Even if you see a Twitter search, right, those trending things, they are real most of the time, it's very real time, right? So it might be happening hourly or something, the trending thing, uh, that could trend because the user is searching, right, that thing quite frequently. Then it can become trending, or there could be other things like retweets and likes and stuff, but yeah,
Yeah, I agree.
search.
That is a con of weekly. If you want trending searches, then it's a con because some event happened yesterday, but I'm not able to get auto suggestion for
Yeah,
that today.
yeah, but
probably-
hmm,
yeah, like probably like for trending, there could be like I mean different flow altogether that
But
gets.
but how would you know it's a trending phrase or it's a normal phrase? Like how will the system know? It's kind of the same thing for the system, right? So it depends on what interval you use, whether you update it early or you do it weekly, as
yeah.
per my understanding.
Yeah, I think let's say if we are designing our search, right, so this ought we are not we the important thing here to understand that if we are designing a system for trending search, then it would be very different from a system we are designing for autocomplete search. So we should kind of think in perspective of autocomplete search for this particular thing, but not for trending search.
Right, right. Yeah, WhatsApp does not need the trending search part, right? Whenever we
Mhm.
type, it's a, basically a English words auto suggestion. So it's not dependent on the trending search. It's only dependent on the auto completion part.
Hmm.
So there we don't need to update every early. I think weekly is fine because we are not introducing new English word every now and then.
Yeah,
But for Google search, it should be kind of different because there are trending searches.
exactly.
New
So like I have worked on like autocomplete service.
Okay.
So
Right.
like basically like what we had, I mean there was like different popularity service altogether. So that basically computed actual popularity. I mean popularity. So I mean that could be that can take like different things into consideration, right? Like the searches and then yeah like inventory update and all these things. But yeah like oh sorry, purchases, orders, and all these things also it can consider. But yeah but yeah, like for autocomplete we used to have like kind of daily frequency for updating
Yeah, I think this could be one of the interview clarification question, that whether we need to update it daily or not. So based on that, we can proceed with our design. So yeah, so here they are also suggesting that we should ask, right, to verify that is it important for real time. Otherwise, they for now assume that it is weekly updated. So yeah, for as we discussed, like I think for trending search, we have to do it real time. But for I mean this kind of search, yeah, same example they have said about Twitter here. But yeah, okay, let's move on. I think we had a good discussion around this. So frequency field is the sum of the occurrences in that particular week. It is an aggregated sum. Okay. So for example, when you have this query, then we are using workers, which are asynchronous jobs that kind of update your trie, which is here these workers, right? Once you get the data, then the workers will update into the DB.
Okay, so for the new data, we are aggregating it in a kind of table structure, right? And then we are updating it in a try after a time.
Yeah, we are updating it into aggregators,
But the
and
data set uses some kind of table or database, right?
So yeah, or it can be like, I
It
mean,
makes
like it
sense.
can append only logs or something like that also. That
Yeah,
can work.
yeah. It can write to append only log, but it also needs to increase the frequency, right?
Yeah.
So I think a table or a database is a good structure here for a while. In memory table will work here, and we can
Mhm.
keep on the frequency for different places. And when we want to write, we will update it in a try. We will,
Okay.
yeah, that makes sense.
So there's a DB. So there are two choices, like what kind of DB would you have. So they are saying it could be a document store or it could be a key value store. So like MongoDB could be used here. Other,
Yeah, to be honest, I'm not sure about this. I'm not sure which database is useful for storing try kind of a structure. So,
yeah,
that's new
exactly.
for me.
So MongoDB is kind of strongly consistent, if I'm not wrong,
No, it's a NoSQL database. So
but
it
it
can have the
is.
configuration for a strong consistency, but not always.
Yeah, so if you consider Cassandra and MongoDB, so MongoDB could be used in cases where there some kind of consistency required, because Cassandra is eventually consistent. So in that sense, I feel like here like MongoDB they are trying to use
No, but we don't need strong
consistency.
consistency here, right?
Yeah,
We don't.
Yeah, it's not clear like why exactly MongoDB is a good fit.
yeah, they could have used Cassandra also, but yeah, not sure.
Okay, let's read the second point.
A trie can be represented in a hash table. Every prefix, okay, mapped to a key. Data on each trie node is to hash table, and trie in the hash table. So trie is mapped to key. Uh, every node basically, so every node will have an entry into the hash map, and uh, this there would be some association between these nodes also, right? Who is the parent child, we can also store something like that.
Mm.
Then let's move on. Nothing more is discussed here, just how you will store. They are not talking about how do you maintain parent child, but I think we can store something, association between these two nodes with a parent column or a child column in the same table.
Okay, so that means the try data structure we are storing in the database in form of table only, like hash table only.
But
uh,
how, yeah, like again, like how we are maintaining the like parent-child relationship, like B to BE or B to like BEE or BES.
I think we can figure out that from the keys, right? So if one key is a prefix of another key, that means that is a parent.
hmm.
But that will be like that make it more complex, right?
Yeah, it's not given in detailed view there, but it feels like they are kind of serializing the try data structure into the table only in database, in value database.
Or maybe like it's not required.
So any
Um,
idea, Shubham, in your system where you said auto suggestion feature is used,
yeah,
what
so
type of person? Yeah.
we like I'm not exactly sure, but yeah, like we have used like Elasticsearch and mostly like for autocomplete system and all, like Elasticsearch comes
Yeah,
in the.
Elasticsearch
I'll,
is used mainly for fuzzy searching and all.
not just fuzzy searching, like even yeah, like I mean, like so, like if for product catalog, like we'll have
Hmm.
different attributes. So on that basis, like we will search. So for that, and but yeah, like for query, and then like we used to index like queries also. So query frequencies, like we used to get in some S3, like in some file from S3, and then we used to build index. I'll like take a yeah, like I'll take a like deeper look into that, and then like probably like
Sure, a real-time system can give us more knowledge than this. So
Yeah.
that would be helpful.
So I think this is one of the open question we can have, that how do you store trie, right? we can maybe read it through from
Yeah,
ChatGPT.
and how is WhatsApp or Google search engine basically storing it? So maybe there is some paper we can look at.
Yeah,
We can check the references as well if author has given any such
yeah.
reference. That would
Okay,
be useful.
let's move
Okay,
on.
well, let's go.
Yeah, so query service, as we discussed, that it is responsible for giving you top 5 results for this design. So that is what we will be designing. So here first the query will go to your try cache. If it is present, then it will return it. That is my understanding. And if it is not present, then it will go to try.db and check. And then it will update the cache, and then the response is returned. So something like that we can do. Let's read it what here it's mentioned. So it's sent to the load balancer, then it routes to API servers. If the data is there in the cache, it returns it. We replenish back into the cache. If a cache miss happens, when a cache server is out of memory or offline. Okay. For cache, they haven't mentioned, right, what they will use. Is it a in-memory cache, or is it a
No, cache should always be in
Redis?
memory. For the basic purpose of the cache is to have a low latency, right?
No, but with
So,
so much data in memory, I don't think would be feasible. But
so
some
that's
red.
why we are not storing the complete data. So let's say only we want to store the recent data in the cache part. For the purpose of the cache is the fast searching. So
Hmm.
store only that much data that you can store in memory, but that will help you in the fast searches for the
But do you
client.
think like Redis can also be used here, or in memory is
So Redis is, also can be configured for in memory. So you can configure it for having a persistent storage, but you can also configure that you don't need a persistent storage, so it will be in memory.
okay? Okay,
So
got
I'm
it.
cache and Redis both are fine. No issue.
Okay. So query service requires fast lightning speed. So Ajax request to fetch autocomplete. Okay. Ajax is for like this is quite old thing, right? I read about Ajax when I joined the company 5 years back. So that was the benefit, that you don't have to uh, load the entire thing.
Yeah.
Ajax request basically asynchronous JavaScript. Even if you use Axiom, right, in JavaScript there are axioms, some packages there, that is also a kind of Ajax request.
Okay. I'm not aware about that. I've not
Yeah,
noticed it as well.
Right,
Yeah.
I'm correct, right? I used Axiom right 5 years back. So
yeah.
I'm just recalling that. So yeah. Anyways, let's move on. So browser caching. So for many applications, autocomplete search suggestions may not change. So we can save it in the browser cache. Google search engine uses the same mechanism. Okay. Where they have shown in figure 1312. Here they are saying, okay, never knew this. Maybe I'll check it after the call, that does it really store this. It's showing the maximum age is 3600, means
In
the
seconds.
cache is valid for one
That is
hour
not.
Okay.
Okay.
It's a browser level cache, so I think maybe if you
Client level cache only, no?
uh, but how much storage would
That
it
is
give you? I'm not sure, like the numbers, like did it give you storage in GBs?
So okay, like that means like well, if you go to google.com and you like search something, and then if you search again that same thing, it should give the same results. Let's see
No,
cricket.
that is
client
fine,
is
but
searching
I'm just
here.
thinking
So it's
how
not
much
compact.
total this it can give you storage in the browser cache. Maybe I can
I
just.
don't know the limit, but this thing will not take much storage, right? We
Yeah,
are just
even
storing the
yeah,
picture.
like even they give like good amount of storage. Yeah.
And even if
Fine.
it goes out of storage, it will use some kind of LRU implementation. It will remove the older key in the cache and it will update the new one. So that will be okay.
Okay.
Let's say your cache becomes full before this 1 hour is passed, then it will just remove the older keys.
Yeah, my screen is visible, right?
Yeah.
Okay. So yeah, so now data sampling for large scale logging, every such query require a lot of power and storage. So we will sample it. Okay, just to optimize, I think this caching part.
So many people get confused that why we are losing some data, but it's okay in this case. Like out of 10 requests, we are just kind of considering only one to update our try, and we are ignoring 9 of 10. But that is okay. This is not a hard given requirement from the client, right?
Hmm. Okay, so I think now they're talking about try operation. We already know the creation, the updation. We have two options to update it weekly, update individual. If the size of the try is small, then it is acceptable, right? So how the update operation works. So they are saying like how your try will, again they are coming back to try, where they are talking about creation, updation, and deletion. So this, the second approach, they are saying it's not scalable, where you will go to every node and update the node directly.
Okay. Then what is the optimal solution?
This one first one.
Okay. Yeah, real time updation we should not do. Yeah, we were clear about that
Yeah.
from the start, right?
Yes. So the next thing is the deletion. Like if there are some searches which are not rightfully intended to the user, for example, terrorist or something like that, or some hate speech or something, we can remove those words and add a filter, even though it is trending or maybe most searched. Then we have to filter those. So user relevant searches are there. So yeah, makes sense. So this is, I mean, just I think I don't see it's required in real interviews, but yeah, just a good point, like you can filter and stuff. Scale of the storage. Okay, so note that we have developed this. Okay, then you are sharding it like on the basis. First approach is kind of to shard it based on alphabet, but what if
Right.
your alphabet becomes very hot? So there would be uh, that problem, right? What do you call it? Hotkey problem, something like that. So,
Mhm.
so that would increase the load on a single server or a shard. So that is not scalable. At first glance, this approach seems reasonable. This creates uneven distribution. We analyze the historical data distribution pattern and apply smarter sharding logic. For example, if there are similar historical queries, we can maintain two shards S and U to Z. Frankly speaking, I don't understand like what they are trying to tell. This part I understood that based
Yeah,
on the.
how they will manage, like how, I mean, like one thing is like they can have a uh, dynamic sharding, like let's say at present like A has 10, B has 12, and like C has 15. Then yeah, I mean distribute it accordingly. uh, but yeah, like let's say A increase to 30, then yeah, like give one shard to this and then basically combine the rest of the shards.
No,
But yeah,
they
like
are
that
here
will,
saying that you can split it into 26 servers where the queries starting from A to Z like would go in different servers.
yeah, yeah,
Right.
like
But we need to balance it dynamically. So when new queries are coming in, you should be able to create a new shard and update your mapping.
yeah, like there will be shard, like what we say, like repartitioning happening on these
Hmm.
shards, right?
Rebalancing or something.
Rebalancing. So that won't, um, I mean, that would be costly.
But
Not sure.
what is the historical thing? How would you shard it based on historical? Are we saying that? Uh,
Okay, like for till now, like what all, starting from S, how many prefixes are there, or starting from U, how many prefixes are there?
hmm,
So based on
It
that,
seems
like
that we have seen in the past that for S, daily query is coming as 50,000, and from U to Z, they're also coming in range of 40 to 50,000.
hmm.
So it's better to have a single shard for S and separate shard for U to G.
Exactly, yeah, that makes sense because otherwise your resources are wasted, right? You are making separate shard for U, V, and Z, but they are actually your queries are less, right? The traffic is less, so the resources are getting wasted. So basically, we can combine all of them into a single thing, and another could be for S, maybe. Yeah. So that is how we can solve this. Yeah, makes sense.
yeah, yeah. But like one thing is like, so let's say now like you have given one shard to S and like U, V, W, X, Y, Z has like what U to Z has one shard. Now let's say your queries on S decreases and like W, X, and Y increases significantly. So then like you will separate out like V
Hmm.
from your set, and like then you
Yes.
will have to, if you're separating out V, then you will have to what, like copy, I mean like shift data, right? Copy
Hmm.
data,
Right. They
Yeah.
have to add a new server and basically add a shard for WX and then separate shard for Y and G and then rebalance it. So in Map Manager,
rebalancing.
this mapping will also change, and that's how web server will know that from Map Manager that where should I go to and to fetch this, and then yeah,
Hmm.
it will fetch from
Yeah,
that
makes
particular
sense.
server.
So this is a critical thing. Like if we are designing something, then there should be a manager also which should have this mapping, right? So this.
That can be
Right.
costly, right?
No, why it would be costly? It's just a table, right? A single
But
table.
it has to happen. So every time, whenever you introduce a new system, your data will grow rapidly, like month by month. So you have to do this kind of scaling and data sorting every now and then. So it's required in I think every
Yeah, and
system.
Okay.
even let's say if you have this, I mean, whenever you are implementing, let's say a shard, so there would be a shard API or something which figures out like which exact shard you have to route the data. So, this can we consider the shard API as sort of a shard manager?
Okay.
Does this sound okay? I mean, or so for example, you have S0, S1 shard, and here this API decides which shard you have to point. So it has some API logic which essentially your it would be some file, some config file
Yeah.
where it has some mappings.
Yeah.
That logic can be abstracted in the shard API. Yeah, so I think so. Yeah, that makes sense.
Yeah, I
Okay.
haven't come across like any like real time problem in this.
Yeah, I have worked on a system where
Same here.
sharding is used. So in that, basically, let's say you have an inventory management system, and in that you are having a lot of warehouses, right? So in a particular city, there are a lot of warehouses, and inventory is coming. But the software which you are using for that warehouse is same. That means you and a lot of warehouses. So obviously there would be some warehouses where the volume of inventory is large, and so you have to decide like through the shard like which you have a single. Let me explain. So there is a single. API, which we can call is as a warehouse API, which decides where you have to store the data. So the schema would be same, like inventory ID, how many inventory have come, and like stuff like that would be there. So so it decides like some would have a larger volume, so we can say that most critical or large appliances ones can be here. uh, I mean so let's say warehouse ID from some there would be some, I mean, identifier to check whether it's a large warehouse or something. So we can say it, warehouse ID that starts with let's say large or something would be here, and something like this. So that's how you can implement a sharding, that whenever a request is coming, because your software is same, right? The user is using the same software in your this is the UI, let's say UI. So now they are using the same software but in multiple warehouses at the same time. So how are you going to define where the data is going to store? So that is how you can differentiate, so that the load is distributed in these shards.
Okay. Yeah, like I'm like talking about like more of that sharding rebalancing problem. But
No, so you
like
want
that.
to avoid that, right? But in this particular problem, what you meant is, let's say if we change that, right? Some u to v, and then we have to rebalance.
Yeah.
But so in every system, you need to do this, right?
Hmm.
Data rebalancing and sharding.
Yeah,
So
mostly like how do they do is that they
Yeah.
have some sort of scripts and all. So let's say this replica, your replica is not in sync with the previous one, then you have to fill in those holes are created in your partitions, and then kind of a script runs which checks whether basically how it happens. What I think, I have not closely worked, but what I know is that it keeps some sort of timestamp or something, that this got updated at the t1 time and this got updated in t2 time. And let's say this is your one partition and another partition is correct me if I'm wrong, but something like there. So till here your data is in sync, right? Till here your data is in sync, this is fine. But now you see that your data is in sync from here to here, like I mean this portion is sync, but here you the data is not sync, so there is a hole. So it will try to balance it and fill it so that both of them will become in sync.
you are talking about replication, not partitioning part, right?
uh, yeah, I mean replication also, or let's say if there is a difference between master and slave.
Mhm. Okay, understand.
Okay. Yeah. Like
But that is what will happen in this case also, right? Will it be different, like if they are not in sync and you are trying to rebalance it, then also again we have to do similar kind of activity.
Yeah, it will be kind of similar only. I agree.
Because at the end the data should be same, like a to z or u to
The
z.
difference is that there you are trying to replicate the data, that you are copying the data, but in case of rebalancing that we discussed in type ahead, you are migrating the data.
Okay.
okay.
Yeah, exactly.
That is the difference. Yeah.
Entire thing is migrated. So maybe we can maybe dig down under this thing, that how do we do
Rebalancing.
rebalancing when the
Maybe.
sharding
Yeah.
servers are changed, something like that. We can think maybe these
Okay.
these two, I'll post in the chat, maybe we can check.
Yeah, and you combine these two questions with the question we discussed in YouTube discussion. Like for every discussion, can we combine all the questions that we have? Some.
Yeah, I can do that. Last
Okay.
time I think we didn't capture anything, but if I have something in my mind, I'll add.
So,
Yeah. Okay.
okay.
So I think we are done. So
Good
multiple.
job.
Yeah. Okay. Yeah. So I think here they are talking. Let's read it through. Like some inputs would be there. It won't take much time. So to support other languages, if you're not familiar with Unicode, this I haven't personally worked with, but I've heard a lot about it. That you can have some Unicode thing, which is language agnostic.
Okay.
Okay, I'm not sure about that.
Yeah. So that is how they kind of use this Unicode.
I thought for Hindi word there will be a separate try or something.
No, no.
I didn't know that there is
Yeah,
something
it
called
will
like
try to
Unicode.
convert it into a Unicode and then store.
Acha, okay.
But
I think
that would be really complex. Yeah, but yeah. Let's say
so.
if
I
you are
think
typing something in Bangla and then you are trying to convert it into Unicode, that is a different challenge. But I don't think we use it. Mostly, maybe some common languages could be done. I'm not sure.
Nishit is saying something. No, I was like, I think Unicode has for Hindi. There are characters you can use.
Yeah, like that's what it is trying to say. But
Yeah, I'm not aware how that works. I thought for different language there will be a separate try. That was my assumption, but this is something I should understand.
Yeah, and for like global search, they are using CDN, so we already know that. Then a search query suddenly becomes popular. Our design will not. Obviously, we are doing weekly, so how would it work? That is fine. And building a real-time autocomplete is complicated and much beyond the scope. Set reduce the ranking, check the ranking model. Then streams. So has anybody work on Flink? Like I was reading something where like we can use Kafka, like we have some Kafka events and we put it into Flink and it will kind of uh, do what do you say that word? I'm missing.
transform.
Transform, yeah. So transform, by transform, does it like I mean, does it update that Kafka event? Why can't you do it through Kafka itself?
Yeah, like Kafka Streams also supports transformations and all that.
Hmm.
So yeah, like I mean, there would be like some different purpose if you are going for Flink nodes.
Kafka can't do it. So let's say we are logging a matrix. So whenever I click on a button, a matrix is locked. Now I want to query that for a last minute, how much time that button has been clicked. So what? So my event will go through Kafka, but what Flink will do, it will consume that message, and for that click, it will keep incrementing the count in memory.
Hmm.
So for let's say every minute. So it's kind of aggregation that it is doing
Yeah.
on the Kafka event.
And that is real time, right?
Yeah, and there are different kind of aggregation that Flink supports. Like
Yes.
yeah.
So what I remember, like one of the system I worked upon, I actually worked upon, but I forgot. So basically, what we were doing, we were getting those DB updates, right? Let's say you are updating a DB, so those DB updates are happening, and obviously, like there is a Kafka, and also whenever DB updates is happening, then a Kafka event is also there. Then that we are aggregating into a Flink, and that is then pushed into the GC, that Kafka streams. That Flink CDC pipeline kind of thing is there, and
Yeah, so
that is
yeah, CDC is like basically from your let's say in your database, like some MySQL database. Then from there, like all the update events, update, insert or
yeah, yeah.
delete events that are happening. So there can be some DB. Like Amazon has like DB. What like
DynamoDB streams. DynamoDB streams.
no, not DynamoDB streams. Like some DBS jobs or something. DMS, sorry, DMS jobs. So that basically stream like I mean like yeah, like all the insert like upsert operations on your MySQL database. So that is created as an event. Now like you can use and sync as some like Kafka queue or Kinesis, like Amazon has Kinesis. So there like and there you can define policy like basically like I mean if it's consumed once, then basically destroy it, or you if you want any particular retention, then you can define that accordingly. And then yeah, I mean for the DMS job you can define the sync as like kinesis, and then you can use some lambda that will feed that will basically listen onto that onto that kinesis on particular topic or something, like however you define your like DMS job. And then yeah, like your lambda can process all these upsert operations and then can do aggregations and all. So you can replace this lambda as with Apache Flink also. I think Amazon had like AWS, there is some service also that is equivalent to Flink.
Okay. Okay, yeah, we can like maybe check like how we can do the streaming, and I think there was some aggregation with GCP, and then that GCP job is
Is Kinesis alternative of Kafka?
Yeah, like
Kinesis.
So what is the difference between SQS and Kinesis? Like AWS has both services, but I'm not sure what is the difference.
SQS is more like a message queue, and
yeah, like it's
Kinesis is like for processing.
So Kinesis is, I can say that it's a in-house, basically alternative of Kafka.
like Kafka streams. I mean, like you can configure it in a way that you can
Yeah, I think
use it
it's
as a
used for
replacement
some. Is that part of the ELK stack, right? Elasticsearch and Kinesis, right? So maybe it's used for some analytics, like how many users have clicked it per your event or something. So it kind
ELK stack is different. ELK stack is like case Kibana, not Kinesis.
It is
Can you
not
say data stream processing and Kafka is also data stream processing? So I thought it's kind of
Yeah.
alternative.
I think when you say Kafka, there are two use cases. One is Kafka can be used as a message queue, or Kafka can be used as a streaming processing also. So depending on that,
Yeah.
that's
I got one article.
So you are saying Kafka is a superset and Kinesis and SQS combined are subsets.
that's what I feel. Yeah.